Let's look at this probability / counting problem. An integer between 1000 and 9999 inclusive is chosen at random. What is the probability that it is an odd integer whose digits are all distinct? I think this problem has been made easier on purpose because it has a constraint that is between 1000 and then 9999. If it relaxed this constraint, it can be a little bit more interesting. So we will consider that afterwards. Let's look at the original problem. All right, let's remove that. Okay, so there's a number between these two numbers. So by definition, that number is a 4-digit number. So good. Right? So this is a very good hint on how to do this problem. And there are constraints for this integer. First, it has to be an odd integer. So what does that mean? It means this ones digit got to be an odd number. And it also says all digits are distinct. All right, let's pick the last digit first. This last digit got to be from 1, 3, 5, 7, and 9. It got to be one of these 5 odd integers. So we have 5 choices. How about the other 3? Actually, we should separate the first digit with the other 2 because these 2 digits can take a value of 0, but this cannot. The leading digit got to be an integer greater than 1. So let's consider this digit first, the first digit. And it can only pick a number between 1 and 9. But remember, 1 is already taken. Not the number 1, but one of the 9 digits has been picked for the ones digit. Therefore, we don't have 9 choices. There are only 8 choices. So for the leading digit, it can be one of the 8 numbers. Good. Then we can make a free choice for the middle 2 digits. So 1 digit has been picked for the leading digit, and 1 has been picked for the ones digit, the last digit. And for the middle 2, actually from 0 to 9. And less 1 for the first and 1 for the last. So these are 10 digits and minus 2. So we have 8 digits that are free of choice. We can pick any of the 2. And at the same time, we need to consider the permutation. Therefore, the choices will be times 8 times 7. This is considering the permutation. So what is the product? Let's see. Okay. The question is actually the probability. Therefore, we will leave this product as it is. We will not compute it for the moment because it's a large number. When we calculate the probability, so some numbers may cancel out from the denominator. Then we need to count the total number of 4-digit numbers between 1000 and 9999. And that's easy to compute, right? So that'll be 9999 minus 1000 plus 1. And that'll be 8999. Actually, let's not do that. So this plus this, that gives actually 10,000, right? Minus 1,000. So this is a lot easier. So that's 9,000. 9,000. All right. Then the probability will be 5 times 8 times 8 times 7 divided by 9,000. Whoa, this is a big number. So let's break it down. So we know that 9,000, that equals to 9 times 1,000. 1,000 is 8 times 125. Good. So this cancels that. The 5 cancels this, gives 25. All right, so the ending result is 8 times 7 divided by 9 times 25. So that's computed. So that's 8, 7, that's 56. And 9 times 25, that gives 9 times 5, that's 45. And carry a 4. 9 times 2, that's 18, plus 4, that's 22. So the end result should be 56 over 225. 56 over 225. So B is our choice. Good. As we mentioned earlier, that this constraint has made this problem slightly easier. So what if we relax that? And can we still compute the probability? Let's give it a try. I'll clean up some space. I'll clean up some space. All right. Without this constraint, things become a little bit more interesting. Now, our possibilities are not just 4-digit numbers. We may also have 3-digit numbers, 2-digit numbers, and a 1-digit number, right? So for 1-digit number, an odd number is 1, 3, 5, 7, 9. And of course, a single digit, of course, the digits are different. So that'll be 5 choices. So we need to plus 5 here, right? Those are the good numbers we want to choose. And how about 2 digits? We'll have from 10. So we need to consider different cases again. We need to subdivide the cases to 1 digit, 2 digits, 3 digits, and 4 digits. Now let's focus on 2 digits. All right, so that's 2 digits, and this is 3 digits. So for 2 digits, hold on a second. So we need to update our numbers, because here we update 5, and also we need to plus 9, because normally we only consider the natural numbers, which are positive integers starting from 1. So we have 9 possible single-digit numbers here. So if we want to start from 0, here will be 10. So let's start from 1. All right, so plus. Okay, for 2 digits, we'll have, first, it got to be an odd number. Then the 1st digit got to be an odd number. So it got to be 1, 3, here, 1, 3, 5, 7, 9. So we have 5 number of choices. All right, and how about this one? So this one can take a 0, because it's a 2-digit number, right, like 10. So this can be any number between 1 and 9, but less one more number which was chosen for the 1st digit. So that's 9 minus 1 equal to 8. Therefore, the possibilities are 5 times 8. So that equals to 40. Let's put 40 here. And at the same time, let's plus all the possible 2-digit numbers, right? So there are from 10, let's put it here, from 10 to 99, right? How many are those? So that's 99 minus 10 plus 1. So that's 100 minus 10. That's 90. Let's plus 90. All right, for 3 digits. So let's clean up a little bit more. Okay, so for 3 digits, it'll be something like from 100 to 999, right? 3 digits. We will use the same principle as the 4-digit numbers. So for the 1st digit, it got to be one of the 5 odd numbers. So we have 5 number of choices. Okay, now let's look at the leading digit, which is the 100th digit. It got to be picked between 1 and 9. But one of the 9 numbers has been reserved for the 1st digit. So we have 8 left. Good. And this middle digit can be anything between 0 and 9. But 2 numbers has been chosen for the leading and the last digits. So our choices will be 10 minus 2. So we have 8 choices for the middle digit. Therefore, the quantity here is 40 times 8, that's 320. So that's plus 320. Okay, how many possible 3 digits do we have? So that's between these 2 numbers, right? Again, it's 100. No, it'll be 999 minus 100 plus 1. Again, that's 1000 minus 100. That's 900. So that's 900. So this equals to 9999. Good. And actually that's between 1 to 9999, right? So this is easy. And we don't have to do all the calculations here and here. And for this one, we'll do the calculation and we'll get some numbers. Then let's say that's a star. Then we'll take a ratio. Star over 9999. So that'll be our choices. Therefore, what I want to point out by this extra example is that when you do the counting problems, in many cases you want to do the casework. You want to split a big problem into smaller and easier to handle ones. At the same time, all the scenarios you got are distinct. So you can solve the different scenarios one by one and then sum them up. And that's always a useful trick you want to consider. Alright, that's so much for this problem. If you like this video, please subscribe and thumb up. If you have questions, please comment.